Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome in our new members and like to kindly request that we go to YouTube and search Ernest Sciences and Mathematics TV channel. Subscribe to our channel and engage us on the comment section so that we can be having these healthy discussions of engaging one another in various topics of mathematics, physics, chemistry and biology. So for today, we're going to look at a specific concept which spans across chemistry and physics. And of course, it's going to be heavily relying on some of the various areas that we have looked at, especially in integral calculus. And we have done part of this specific topic, of course, in areas which, of course, we have tackled on decay, or rather some of the areas that we're going to see, which are going to involve the concept of decay series. So in this specific aspect for today, we're going to try and look at the foundational concept on the radioactive decay. And in our introduction video to radioactivity, we had said that radioactivity basically refers to the spontaneous disintegration of a non-stable atomic nuclei. And this was accompanied by a release of energy and particles. And we had said that this energy is basically in form of radio or rather electromagnetic radiation. Now, given a rough illustration on how we can be able to figure out how this specific concept of radioactive decay occur, or rather the radioactivity, and we have said that this phenomenon had been given these different descriptions or input from various scientists over time. So today we're going just to look at a summary of some of the inputs that were done by some of the scientists over time, and try to see how those ones are relevant in our discussion for today. So basically, therefore, I'm going to give you just a few illustrations on the board, which are going to assist us summarize on various aspects that we need to know on the concept of radioactive decay. So basically, this is going to entail this figurative illustration I've given on the board. And of course, I've said that this is going to be a process that is going to be spontaneous. And this is going to be accompanied by what the release of energies and particles. So in the first case, we're going to see that one of the forms of energy which is going to be released from this radioactive decay is what we refer to as the gamma radiation, which of course is going to be indicated using this specific initial that I've given for this. So this gamma radiation is one of the radiations that we're going to see being the product of a radioactive decay process. And next we're going to see that there's going to be another kind of course, emission which is going to be referred to as beta. So for the beta emission, we're going to see that there is a contrasting characteristic between these various products of radioactive decay that I'm mentioning. So in this particular case, I'm going to mention a few, or rather just a few characteristics of this specific radiation that I'm listing on the board. And then we have what we call the alpha particle as a form of a product which is going to be, of course, given as a product of this radioactive decay processes. Now, this various, of course, so I'm going to give this one. This is going to be a beta, and this is a form of energy, therefore it's going to be gamma, and this is going to be an alpha particle, which is going to be given as that. So this one also is going to be a particle which I've given as a circle. So therefore, these are the major products which you're going to see. But in some areas, we're going to look at different aspects of these emission processes concerning the electron capture, the positron, neutrino, and other areas, which I'm going to mention later in our following videos. So in this particular case, if you try to look at this basic product of radioactive decay, we're going to see that the beta, of course, emission is going to be a high energy electron. And we're given the concept of this specific electron as a symbol for the E negative given as such. So whenever we're going to represent this specific type of radiation, it's going to be represented as either an electron or the sign for beta, which has been given a negative sign as the one that I've done on the board. So therefore, that's going to represent what we refer to as the beta emission. And then we're going to have the gamma radiation, which basically is going to be a helium nucleus that can be represented from our periodic table. We're going to have this one given as 4 for the, of course, the mass number, and then the atomic number given for 2 as such. So whenever we're going to represent this one, the gamma radiation, then therefore it's going to be given as such. And now, and for the, so basically this is going to be the alpha. I can be able to just illustrate them on their respective illustration that I've given on the board. So this is going to be the alpha particle, which is going to be represented by this. And then we're going to have the beta one being represented as P negative as such, or an electron as I've indicated. And then for the gamma radiation, this is going to be a form of energy, which is going to be given a symbol that I've given on the board. And in some way, we're going to look at the various or individual characteristics of these various products of the radioactive decay, which are going to assist us, of course, try to quantify how we can be able, or rather quantify these kinds of radioactive decay processes. So in our next video, we're going to look at the various ways in which we can be able to describe this alpha, beta, and gamma radiations in forms of equations. And those are going to assist us, of course, in trying to pinpoint various products of the actinium, the uranium, the thorium, and of course neptunium series, which we had discussed for the natural and artificial radioactive series in our previous video. So for today, I wanted us to know the symbols and then how we can be able to represent the various radioactive decay processes. And of course, from this, we're going to look at the individual processes, as I've said, and their various characteristics in our subsequent videos. So catch us in our next videos. We're going to look at these various characteristics and try to see how we can be able to represent these ones in form of an equation. So for now, we'll just stop there. Kindly check on our description boxes for various videos on the same topics, and perhaps they're going to create for us a relevance, or rather we're going to, of course, have a complementary way of trying to understand these specific topics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.